How is everybody? I got in at 6 a.m. and then I still came here and I'm talking to you, and that was the best you can do. How is everybody? There you go. So I've seen Jed present before. He's pretty slick, right? So instead of actually doing anything with Keynote, I drew all my slides on my iPad, because that way I don't have to compete with Jed, because he would win. So yeah, this is, I talk to a lot of people, I write a lot of Node code, and one of the things that seems to be a reoccurring problem for people is that we're exploring this whole new paradigm with server-side JavaScript, and in particular Node. I think really when we talk about server-side JavaScript at the moment, most people think of Node and the event loop has a really specific set of problems that people aren't used to. We program in a particular way from the browser, but it's not exactly the same. So I thought I'd write this. This is how do we really stop writing code that just looks like ass, and how do we do something with that? So there's a warning. I'm going to use a lot of metaphors. So I don't know. I probably have a total of 20 lines of code in this whole presentation, but there's going to be some extremely bad metaphors. So be warned. But what I really want to do is explain how this works rather than dazzle you with code. Tim did an amazing job yesterday of explaining this stuff, and I think his slide deck is great reference material. Go and read his code, go and sit and digest it. I'm a little bit less smart than Tim, right? I sit with Ryan and I watch these guys and I'm like, oh. So instead of trying to do it that way, for me, I try and tell myself a story. I try and figure out what's the simplest way that in my head I can understand how this stuff works. And the thing that we really need to understand is this event loop thing, right? And everybody has talked about it this week. Everybody's been going on and on about the event loop. But I have this theory. I believe that people really get event-driven programming. So I cook. Hands up people that cook. Right? Hands up people that can cook more than just ramen noodles. I don't know, you're geeks, I have to ask that, right? So if you really cook, if you actually have a kitchen and you have chef's knives and all of this stuff, you know that people intuitively get event-driven, right? You sit and you're cooking and you're chopping something and a pot starts boiling over. You don't finish chopping, you stop and you deal with the pot and you turn the heat down, and you're used to that idea that simultaneous things happen and we can deal with that. And yet, where did this fallacy come from that, oh, well, programmers can't think, in multiple things. They can only think in the single, you do this, then you do this, then you do this, then you do this, then you do this. In our everyday lives, we're constantly interrupted with things and we deal with them. And then we carry on and we do something else. This is just a normal human behavior, and it's something you intuitively get. So how do we get to a place where we're trying to write code and we don't understand what we're doing? So here's my second increasingly bad metaphor, the event loop postman. Right? This is kind of silly, but this is the event loop postman. He's a happy postman. He's delivering letters. And his letters are the event stack. So he's got his stack of letters, he takes a letter one at a time, and he walks to the house, right? His route, the sort of red squiggly lines, are the callbacks. I've got a letter, and I walk through my callback, and I deliver the thing, and that's the end of the callback, and I'm done, right? I then go and get the next letter, and I walk and deliver it. Obviously, he's not a very good postman. He can only carry one thing at a time, but, I mean, I did explain there were bad metaphors, right? So this is this really interesting thing that we're using. But the problem is, for our poor postman, I'm a real bastard and I have a gate. So the postman walks up and he's like, great, I'm going to deliver the letter. Oh, there's a gate. And he walks around and he's like, oh, there's a gate. and he walks around. Can you guess? Oh, there's a gate. So our postman is stuck in this situation where the only thing that he knows how to do is deliver his event, and he's trying to do that. But the gate's not open. And you say, well, okay, it's event-driven. What if we have something that's going to open that gate and it's waiting on the stack? It's another event, and we're okay because it's going to fix it for the postman. Well, the problem is the postman's never going to deliver the letter that opens the gate because he's stuck trying to deliver the letter that requires the gate to be open. Ow. So this is what's really weird and interesting about the event loop. And I think this is one of the things that I really wanted to communicate is that things only happen one at a time. You have to finish a callback before you can actually continue and start getting events. And I'm going to show some code in a minute, but this is a really interesting problem about how do we do these things. Node is incredibly fast. It's incredibly scalable. You can have thousands of connections at once, but all of that relies on having an event loop that's working. All of that relies on the fact that each of the events happen very fast, and then they go away. So we can take away things. We can use not to go to the file system. There's a separate process. It's non-blocking. You get the callbacks. You don't have to deal with that. Great. You know, if you want to read from a database, if you want to do something over the network, all of these things are non-blocking and you don't have to deal with that. But you can still block your own event stack. And until you really understand the fact that you have to finish execution, then you're going to be in trouble. So this is a piece of code that will tie up the node event loop forever. And it's really simply obvious how it works, but what we're going to do is we're going to include the event emitter. So we've included Node's event system. We've created a new event emitter. I've created a simple variable die, and then we have a function. So we want to emit on the die event. We're just going to set die to true, right? And we're going to set a timeout, and the timeout emits that event. So after 100 milliseconds, it's not very long, really, we're going to emit the event die. And then we have a while loop. So while not equals die, loop, and then finally console.log done. If you run this code, Node will just run until the stack crashes. Because it sits there and set timeout in order to fire that event will never happen because it's stuck in a loop. And more than that, so this fits on a side really well, but if you start having other things that are event-driven, and you're expecting those events to fire that would, make this loop quit, they will never fire because the loop's busy doing stuff. The postman's walking down his path, and he's walking down his path, and he's walking down his path, and your event is never going to fire until he's finished walking down his path. And that's a really significant piece of information because if you write code that blocks yourself, nobody else is going to help you. Now, this is kind of facetious, right? Nobody's really going to, having like big while loops in code that rely on events to fix them is it's a strange use case. But it's completely possible for you to write extremely long-running code that maybe won't block your event loop forever, but it will block your event loop for long enough that it will cause you some pain. And one thing I would mention is that things like TCP connections, when you get a new TCP connection to Node, that's a separate process. It's handled by the kernel. The kernel will stack up the TCP requests. So Node's not going to randomly drop them because you've been busy, for 100 milliseconds or 1,000 or whatever. It's going to stack up in the kernel, and you can still accept them. But if you tie yourself up, that's a problem. Unicorn break. Yeah. Unicorns crack rainbows. It's on my T-shirt. It must be true. I just wanted to inject. We haven't had any unicorns in the conference, or hardly any. So it's not JSConf unless there's unicorns. No? Vapor.js? Yeah. So what are we doing with this stuff? What are we actually building with Node? And what are the patterns that we can sort of use by really knowing how the event loop works? What are the things that we can do to make this useful and to not write things that hurt us? So the kind of cases, the common cases that people have, web servers, command line stuff, and then maybe peer-to-peer. So like these are the kind of cases. It's not actually web servers. I personally have written a DNS server. It's not great. It's going to get better, hopefully, in the future. But we have a DNS server written in Node. It's kind of scary and wrong, really, to write DNS in JavaScript. But scary and wrong things are kind of hot, aren't they? No? So, you know, it's any sort of server that has, you know, some kind of client response model. And these, for me, are like the three, more or less, the three kinds of apps we're writing. So the CLI pipes, this is really simple. This is a use case that we can more or less throw away. Because if you're writing stuff for the command line, it's pipe in, pipe out, right? You have something that's standard in, and then standard out. It doesn't have to be asynchronous because the command line is never going to treat it asynchronously anyway, so who cares? This is not a case that I really care about. It's not interesting. You won't get tied up writing Node code. You won't get confused writing code for command line stuff because it's just in and then straight out. The cases where it's more interesting are these ones. So if you look at this stuff, essentially we have two cases. We have things with streams, such as TCP, you know, and there's lots of things, but things like PTP, anything where it's not discrete connections. And then we have this discrete stuff. So I receive an HTTP request, and I send it a response. I receive a UDP request, I send a response, right? And the fact that these things go over over TCP as a protocol doesn't really matter. What the server is doing is discrete requests. And this is actually our biggest use case. So I have a request, and I give a response. It's request-driven. You know, our server receives something, and it's expected to give something back. So how do we architect that in a way that works? So here's some code. Hands up people that have used this code or run it. Yeah? This is the code from the front of the Node.js page. So what? I counted like 6 hands. 6 people have run Node. Really, come on, hands up people that have really done this. Thank you. Right? So you've all run this code. So this is sort of the 101 example. And what are we actually doing with it? Well, we're getting a request, and we fire a callback, and that callback is an anonymous function. Right? We're just, you know, doing a really simple example, but the problem is that people start to do this. And, you know, Jed's right, I call this pyramid code, but it basically, it looks like that. And I think actually Tim probably coined that. Yeah. You know, but you end up, you have like all of these anonymous callbacks that nest together, and you end up with this giant pyramid of code that just sticks out at a weird angle, and it's really fucking ugly. It really, ugh. And it's hard to maintain. You can't read it, and you know, you create all kinds of race conditions, and you're like, why does my brain hurt? So my suggestion to you is that if you have this model, this is a pattern. This is a really simple pattern. Have a server. The server has a prototype. This is a pattern that Ryan uses for HTTP. It's a pattern that Tim uses for Connect. Lots of people use it. But inside that, have a request object. Have an object that just has new requests. And just make these all into factory methods. So we have a server. So this could be HTTP. I've used capital uppercase server because it's a class. Create a server, it's factory method, gives us a new server. And then we pass to that a callback. Server.createRequest, and then we give it the request response. So we create a new request whenever there's a connection. And we encapsulate everything in that request object. But here's what's different. It's not an anonymous callback. It's a specific named object that lives within our server. But it lives within the instance of that specific server. But more than that, it's because we've nested it this way, is we can decorate all of the functions into one beautiful encapsulated object, and then you can start to map them, and everything belongs in its right place. All of the requests associated with a specific server belong to that server, but it means that you can create 6 of those servers and everything's sharing its methods really nicely. And it's easy to understand. So then you can draw a diagram like this. So for the DNS server, this is more or less what it does. Takes a request, it passes the request, it iterates through resolve, and then it responds. And this is the point, is once you can start naming what you're doing, instead of having all of these crazy anonymous callbacks, you can actually start to draw a really simple diagram. Does anybody look at that and not have a good guess at what the DNS server does? No? So this is really simple and easy to understand. But if you don't name your functions, if you just have all of this anonymous stuff that's layering on top of each other, it gets really hard to do. And all of these are just callbacks. All of these are, we emit an event, and I just attach them back to back. It's really easy to understand. So the second case is streams, and how am I doing for time? Wow, I think I'm going really fast. Whoops. So the second case is streams, and this is a slightly different case. So you have a socket of some kind, so probably TCP, and you have events that come off the socket. So it's socket-driven, it's doing stuff. Here's some data, or you get external events which you then push up through the socket. What's easy about this? This is a similar but different problem. There's nothing to encapsulate. The socket owns itself, and everything that's event-driven outside the socket, maybe it's a file handle, it can call the socket, but you don't actually need to encapsulate anything. There's no state. It's not like, it's not like, where's my slide? It's not like this. You're not having to, wrong one, that one. You're not having to encapsulate these requests and save them. You're simply responding to events as they come. So it turns out that there's only one real case where people are getting horribly tied up. And that's the case of dealing with these, and it's actually the most popular case, right? I mean, hands up people that are planning to write peer-to-peer streaming servers with Node right now. That guy, Jan, and Tim, 3 people. So it's, the most common use case that people have is some kind of request response, and that's the one that we need to focus on. So I think that this is actually an easy problem. So apparently I went incredibly fast and did it in 20 minutes, but my summary is this. So Doug talked about iteration, which I looked that up on Wikipedia. I think you made that up. Doug, where did you find that from? He made it up. He did make it up. Somebody else should go and create a Wikipedia article for him now. But don't block the event loop. This is really critical. If you block the event loop, everything will fail. And until you understand the fact that all of the event loop has to finish executing what it's executing, that's really critical. And then the next thing is encapsulate. So save the data that you want in a closure. So encapsulate all of that stuff down, and use name functions. So start creating request objects within your server objects and decorate them. Decorate all of them with the kinds of state that you want. And why this is really interesting for me is if you start to think about not blocking the event loop, if you start to think about the fact that we have shared memory, if you can trace and draw the outline of your callbacks, then you can start to remove pieces of memory that you no longer need. You can say, I don't actually need this part of the state at this part of the request process. I can throw it away, and now I can handle more connections because my server has more memory available. And I can start clearing that stuff off and having it garbage collected, and I don't have to wait for the entire closure to be closed. So use name functions and use factories. Factories are great. And then document your flow of callbacks. This is something I've not seen anybody do, right? We're building all of these servers. Where's the documentation? Where do people draw, this calls this, and then this calls this, and then this calls this? This is something as a community we're not doing, and it's really hard to follow. Ryan was talking about how do we debug the stack, and one of the problems that we have is that we lose context, right? Well, it's easy to know context if you've explicitly written it down. But if you're calling everything through anonymous functions, it's really hard to write down what's calling what, which comes back to using name functions. So that was really quick. I guess I'm going to take questions. Hopefully it was useful to people. Questions? Brian? Where was I at 5 this morning? Swing dancing. So, to some weird music, actually, that place played. Yeah. Any questions about JavaScript? Or my social life, I guess that's fine too. They can edit the video, right? Okay, that's it.
Thank you, Tom.